Hello friends. Welcome to this video on the physics chapter of force. In this video, we will cover some important concepts related to force, including types of motion, moment of force, couple, moment of couple, principle of moments, and equilibrium. Types of motion. To understand force, we first need to understand the types of motion. There are three types of motion: translational, rotational, and combined motion. Translational motion is the movement of an object in a straight line, while rotational motion is the movement of an object around an axis. Combined motion is a combination of both translational and rotational motion. Moment of force. Now, let's move on to the moment of force. The moment of force is the turning effect of a force on an object. It depends on the magnitude of the force and the perpendicular distance between the point of application of the force and the pivot point. Couple. A single force cannot make the body to rotate. A couple is a pair of equal and opposite forces that act on an object but not in the same line to produce a rotational motion. Here you must note that force of equal magnitude should not act along the same line, as they will cancel each other and will produce no couple. Moment of couple. The moment of couple is the turning effect produced by a couple on an object. It is equal to the product of the magnitude of one of the forces and the perpendicular distance between the forces. Principle of moments. The principle of moments states that for a body to be in equilibrium, the sum of the clockwise moments about any point must be equal to the sum of the anti-clockwise moments about the same point. This principle is used to calculate the unknown forces or distances in a system. Equilibrium. Finally, let's talk about equilibrium. Equilibrium is a state in which the net force and net torque acting on an object are both zero. There are two types of equilibrium: static equilibrium and dynamic equilibrium. In static equilibrium, the body is in the state of rest under the influence of several forces. Suppose a box is kept on a table and at it is rest. We can say that the box is in static equilibrium because the resultant force is zero when its weight gets cancelled with the reaction force provided by the table. In dynamic equilibrium, the body remains in the state of motion under the influence of several forces. So the conditions for a body to be in dynamic equilibrium are: 1. Resultant of all force must be 0. 2. The algebraic sum of all moments must be 0. For example, when a satellite is revolving around the Earth, the centripetal and centrifugal forces act on it, which makes it stable or in dynamic equilibrium at that particular orbit. Now let's move on to a numerical. Suppose a meter rule is pivoted at its center. Two weights of 40 gf and 60 gf are kept at 40 cm mark and 30 cm mark respectively. What should be the minimum weight to be suspended to make the rule in equilibrium state? At first we will draw the given setup. Given that weight 1 equals 40 gf, weight 2 equals 60 gf. Distance of weight 1 from pivot 50 minus 40 cm equals 10 cm. Distance of weight 2 from pivot 50 minus 30 cm equals 20 cm. To make the rule in equilibrium, we need to apply a force in the opposite side of the pivot of equal moment to make it stable. According to the problem, to apply a minimum weight W3, it should be suspended at its extreme end of the pivot in the 100 cm mark. Therefore, distance of weight 3 from pivot equals 100 minus 50 cm equals 50 cm. So, according to the principle of moments, W1 into D2 plus W2 into D2 equal to W3 into D3. It is because W1 and W2 produce anti-clockwise moment while W3 produce clockwise moment. After calculating, we get W3 as 32. So 32 gf weight is the minimum weight to be suspended in the rule to make it balance. That's all for this video on the physics chapter of force. We covered types of motion, moment of force, couple, moment of couple, principle of moments, and equilibrium. I hope you found this video helpful in understanding these important concepts. Thank you for watching.